On this video, we're going to look at the converse of theorem 4. Name? The converse of theorem 4. This one, you don't have to prove it on an exam, but there are most important information that you must know about this particular theorem, because this is the first in 3 ways. Name? Listen to me very carefully. This is the first theorem in 3 ways where you are going to prove that a quadrilateral is a cyclic quad. No? Yes. This is the first in 3 ways to prove that a quadrilateral is a cyclic quadrilateral. No? It's a cyclic quad. No? So make sure that you tune in here, and then after this, I'm going to reveal absolutely everything about this particular theorem. So what does this particular theorem say? It says that if a line segment joining 2 points subtend equal angles at the 2 other points on the same sides of the line segment, then these 4 points are concyclic. What do they mean by concyclic? They mean that all those 4 points, they lie on the circumference of the circle. No? So here, what they say is that if a line segment that is joining 2 points, a line segment that joining 2 points subtend equal angles, which are this one and also this one, at the 2 other same sides of the line segment, these 2 points, these 4 points, this particular point and this particular point and this particular point, and also this particular point, which means they are concyclic. So from what can we conclude about this particular statement that I've shared it with you here? We can conclude that if angle W is equals to angle U, then we can conclude that the WU ZY is a cyclic quadrilateral. Why do we say so? Because they say that if these 2 angles subtend are equal on the same side of the circumference, which means these 4 points are concyclic, which means another way to understand this particular concyclic, it means also that these 4 points, they touch the circumference of the circle, which means these 4 points, they touch the circumference of the circle. Let me try my best to draw a circle here. So this is our conclusion, which means they touch the circumference of the circle. So that's why we call this that they are concyclic. Remember, this is one in 3 ways to prove that a quadrilateral is a cyclic quad. So if you are given, if you know that this particular angle is equal to this particular angle, and they are subtended by the same arc or a chord, that is subtended by the same chord, which means you can conclude that this particular whole WUSZ, this point touches the circumference of the circle. And if they touch the circumference of the circle, what can you conclude? You can conclude that this is a what? It's a cyclic quadrilateral. They're going to ask you to prove that it's this a cyclic quadrilateral. Yes, is this a cyclic quadrilateral? Why do we say so? Remember, on school, they taught you to see a cyclic quad, you have to see a what? You have to see it. You should see it with a butterfly shape, a pink bow tie shape. A pink bow tie shape. Then you can conclude if this one is equal to this one, and also this one is equal to this one. Then you can conclude that this particular points are what? Are cyclic quadrilateral. Now, if this one is equal to this one, if this one is equal to this one, then you can conclude that this is a cyclic quadrilateral because it's a concyclic. These 4 points are concyclic. Perfect. So from here on, also on this one, you can see the bow tie here, and this particular angle is going to be equal, and also this one is going to be equal to this one if we put the circle here. Perfect. So whenever they ask you to prove that this particular thing is a cyclic quadrilateral, or they're not going to ask you to prove that this is a cyclic quadrilateral, they're going to ask you to prove what? To prove that these particular points that are going to be here, prove that these particular points that are here are concyclic, or they're going to prove to ask you to prove that prove that this particular point touches the circumference of the circle. Ne? They're going to bring this particular question on different form. They're going to ask you that prove that this particular ABCD is a cyclic quad, or prove that they touches the circumference of the circle. Ne? So what you are going to prove, you're just going to prove that these particular angles are equal. Then you are done with this particular proof. This is the first in 3 ways to prove that a quadrilateral is a cyclic quad. Ne? So quickly, I just want you to show you the example on how to use this. Remember the reason that we use for this particular theorem. You can say that converse of theorem 4, or you say line subtend equal angles. Ne? The line that subtend equal angles. Ne? This particular subtend equal angles. Perfect. Ne? So quickly, I take this particular question from the exam of grade 11. So I want us to do it together. So you can copy this particular question, try to do it on your own, and come back and check the answer so that these particular videos can be useful for you. Ne? Because you cannot waste your data just staring at the phone all the time. So it's good for you if you can take some example, try to do it on your own, and see how you have gained since the beginning of these videos. So here we are given a circle ABCD, where we are told that AB is parallel to EF. Remember, what do we know about parallel lines? Remember, on my first video, I talked about parallel lines. I told you guys that whenever you approach the parallel lines, you just remember them as what? As funny lines, because they are fun, they are easy. So from here on, we can conclude a lot of things after seeing this particular parallel lines. But let's read the question. What does the question need? The question needs that we must prove that CDEF is a cyclic quadrilateral. CDEF is a cyclic. You can see, guys, they ask us to prove that this is a cyclic quadrilateral. They are asking us to prove that this is a cyclic quadrilateral. You know, I want also to show you something, guys, before I go far about this. I just want to show you something. A cyclic quadrilateral, a cyclic quad, what they call actually a cyclic quad. I'm going to come on it on our next theorem. A thing is a cyclic quadrilateral if it touches if those 4 points touches the center of the, if those 4 points touches the circumference of the circle. If those 4 points touches the circumference of the circle. Whenever you see any shape, any circle whereby 4 points touches the circumference of the circle, you don't need to be told that this is a cyclic quadrilateral. Just know that if those 4 points touches the circumference of the circle, this is a cyclic quadrilateral. So from here on, guys, you can see that they told us, let's read the question carefully. They are not asking us to, they didn't say this is a cyclic quad. They say prove that CDE is a cyclic quadrilateral, which means there is a possibility that this is not a cyclic quadrilateral, because they say prove. Yes, they say prove. We're going to prove to see if this is a cyclic quadrilateral or not. Perfect. So from here on, sometimes, guys, they're not going to give you a cyclic quadrilateral, which is 4 points here. Sometimes they're going to say something like this one. You see? So from here on, guys, you just have to prove. You don't have to use logical things like, okay, which means just to read about this particular question. That means that this is not a cyclic quadrilateral. Why? Because this particular point doesn't touch the circumference of the circle. We don't need to prove. No. You are wrong if you think that. They ask you to prove. There's a possibility, there's a probability that it's going to be a cyclic quadrilateral, but they need you to prove. Perfect. So without wasting more of your data, let's just get into the point. So from here on, guys, to prove that this is a cyclic quadrilateral, remember, on our previous Converse, on Converse of theorem 4, we talk about if we can prove that things it's a cyclic quadrilateral when we see a butterfly. But from this particular point, if you can take a look here, you can also see a butterfly here, which is this one. So if you can prove that this particular angle is equals to this, or if we can prove that this is equals to this, then we can conclude that this is cyclic quadrilateral, because it will be a converse of theorem 4. So how can we do that? If we want to take a look here, we are given that this line is parallel to this particular line. And we know from our proof, guys, let me say A here, we know from our proof that if angles that are separated by the same chord or an arc at the circumference of the circle, they are equal. What can we conclude about this? We can conclude that this particular C1 is equals to this. Why? Because they are separated by the same chord, these particular angles. Then we can say that angle C1 is equals to angle B1. Angle C1 is equals to what? Angle B1. Why do I say so? Angle in the same segment. Angle in the same segment. Remember, this is our theorem, theorem 4. The original theorem 4. It said that the angle separated. I hope you know it, you understand it by now. Which means this one is going to be equals to angle C. But if we can take a look here, guys, now I just want you to pay attention. If we can take a look here, we can see that these particular lines are parallel. And what can we see about these parallel lines? We can see something also here, that this particular line here, it subtends this particular angle, and also this particular angle here. This is, we call what this one an F shape, which is a corresponding angle. So from here on, we can say that angle B1, which is this one, is equals to angle F1. Why do we say so? These are corresponding angles. Because AB is parallel to EF. AB is parallel to EF. So, but if you can take a look, guys, angle B is both equal to C and also equals to D. If this one was equals to X, this one is going to be equal to X, and also this one was going to be equals to X, or if any number. So from here on, if these are both equal to B, which means they are equal also, then you can conclude that angle C1 is equals to angle F1. Why? Because they are both equals to B. So if this one is also equals to this one, then we have proven that this is what is a cyclic quadrilateral, because these butterfly angles are equal. So therefore, we can conclude from this one, guys. We can conclude that what? That this particular C, D, E, F is what? It's a cyclic quad. It's a cyclic quad. Why do we say that this is a cyclic quad? Why do we say that this is a cyclic quad? The reason for this one, guys, is simple. The reason for this is simple. The reason for this one, guys, is simple. It's because, remember, our converse of theorem 4, we know that if this particular angle subtend what equal angles here, then we can conclude that this is a cyclic quadrilateral. It's a concyclic. So which means this, we conclude this because this is a converse of theorem 4. Converse of theorem 4. Or you can use that particular line subtend equal angles. This is also the same applicable, but this one is very easy to memorize. But remember, we are not also only ask this particular question, we are asked 2 questions. The second question is say that if angle D2 is equals to 38, calculate the value of angle E2. This is a very, very simple one. What I like about Euclidean geometry is that the first question that you are going to answer them is going to give you an opportunity or an easy way for you to be able to answer the next question. So here we are given that this is cos 38, and then we're asked to calculate this particular angle. We know that this DEF is a cyclic quadrilateral. So if this is a cyclic quadrilateral, which means this particular angle is going to be equal to this particular angle. But if you don't understand this, you're going to find angle E in such a way that it's going to belong. So from here on, first we're going to say that CDE is a cyclic quad. Why do we say so? Because this is proven in B, in question B, in question A, in question A. So if you prove something on this particular angle here, if you conclude it, you have to state the reason why, because it is proven. So if it is proven that this is cyclic quadrilateral, therefore we can conclude that angle D2 is also equals to angle E2, which is also equals to what? Which is also equals to 38 degrees. Why do we say so? If this particular one is a cyclic quadrilateral, because you know from the converse of the theorem 4, because of the converse of what? Of theorem 4. No, this is not a converse. Sorry, this is not a converse. This is why, it's because this particular, yes, it's the converse of theorem 4. Yeah, yes, this is the converse of theorem 4. This is the converse of theorem 4. This is the converse of theorem 4. Why we conclude about this? But what I want you to note, is how we concluded to this particular statement that we were asked that this is cyclic quadrilateral. How we concluded? We concluded and said that this because of the converse of theorem 4, or a line subtend equal angles. These are same reasons. So thank you so much for staying with me here. On my next video, I'm going to show you an easy way on how to prove theorem 5. An easy way how to prove theorem 5. So make sure that you tune in and watch my next video. If you find this particular video useful, make sure that you subscribe and comment and share and like the video, and comment your thoughts and share it with your friends. So thank you so much for watching this video. Make sure you watch my next video. I'm going to show you how to prove theorem 5 in an easy way that is going to save you your time. So thank you so much for tuning in with me.